All right, sorry about that, and we're back. So, sorry about that. Like you were waiting for me while I had the video paused. So after the fourth derivative, it's just going to repeat. So, well, let's just see what the values we get are. So Maclaurin polynomial means the center is 0. So I'm plugging in 0 to these things. Remember that sine of 0 is 0 and cosine of 0 is 1. Negative 0, negative 1, 0. And so what's going to happen is we're going to be looping, right? F of 0. So 0, 1, 0, negative 1. Repeat. 0, 1, 0, negative 1. And so if I want to write the Maclaurin polynomial, I can go as far as I want. I can say, okay, p of x, so that's going to be 0 plus 1x to the 1 over 1 factorial. I know it's dopey to write, but plus 0x to the 2 over 2 factorial minus 1x to the 3 over 3 factorial plus 0x to the 4 over 4 factorial. Okay, so like now I'm at the fourth derivative. So fifth derivative will be 1 again. 1x to the 5 over 5 factorial plus 0x to the 6 over 6 factorial. I didn't write x minus c here because c was 0 and x minus 0 is just x. Let's see, so that was 6. So 1, 2, 3, 4, 5, 6. So here's 7. That's minus 1. 8 would be 0x to the 8 over 8 factorial plus 1x to the 9 over 9. I know I was supposed to stop already. Okay, this is way, way too much to write for this. Let's write the simplified version of this. Take out all the zeros. So you might notice sine goes x to the 1, x to the 3, x to the 5, 7, 9, minus, positive, negative, positive, like, shoot, it's all there. We are actually going to memorize this. This is one of the ones that we're going to have memorized. I think there are 4 that we memorize. Cosine's another one that we memorize. And how about you go do cosine, and I'm just going to write my answer for cosine, see if we get the same thing. For cosine, so seriously, pause the video, go do cosine. It's worth exploring. I'm pretty sure I'm right. So let me just yep, okay. So let me explain how I know cosine from memory. So we have sine and we have cosine. One of them is an even function, one of them is an odd function, and conveniently we have their graphs here. So even functions are symmetric about the y-axis. So even functions, if it was like this on the other side, it would be the same shape. It is not. It's like flipped upside down. We'll get back to this one in a minute. But this is symmetric about the y-axis. Cosine is an even function. And cosine's Maclaurin expansion, which is a fancy way of saying the Maclaurin polynomial that I guess goes forever then. The Maclaurin expansion has all the even powers. And you might be like, well, what about the 1? Well, that's x to the 0, right? So it's got all the even powers. And sine and cosine, they both wind up alternating, plus minus, plus minus, plus minus. So the first one's positive, and then the second one's negative, etc. So sine is an odd function, and it kind of breaks down after here. And I don't actually remember the reason why, even though it goes weird after that, it's still considered an odd function, but it's still considered an odd function. So because of this diagonal symmetry about the origin. So because of that, it's, that's how I remember that it's all these odd powers. So, all right, let's see what's next. So we find that the trig function sine and cosine. Oh yeah, whatever. Okay, let's go back to our. No. Okay. Other than asking students to find a Taylor Maclaurin there. Okay, so let's see if this brings anything new to the table. And then we'll stop the video here. We'll stop the video on this page. Like, we'll get through this page and stop. Let's see. Let f of t be a function that has derivatives of all orders for all real numbers. This is kind of a setup they're going to give us when we're going to be able to do an infinite Taylor or Maclaurin series. Don't worry about the infinite part of it yet, but we need that statement because if it doesn't have derivatives the whole way, you can't find the Taylor series. You can't find the Maclaurin series. So if f of 0 is, okay. So I know f of 0 is 5, f prime of 0 is -3, f double prime of 0 is equal to 1, f triple prime of 0 is equal to 4. Right, a third degree Maclaurin polynomial for f. Oh wait, hey, I don't know the function, but I do know all these things. And so I can just say, well, hey, p of x is equal to 5 minus 3. Now Maclaurin, so centered at 0. So that's x minus 0 plus 1, x squared over 2 factorial plus 4, x cubed over 3 factorial. Right? There, all the pieces. There's my Maclaurin polynomial. And approximate -1 to x of f of t dt. So do I just integrate this from -1 to x? But what's x supposed to be? I think we might be missing something. In a momento.